Hi everyone, it's Ms. Lopez. This is your Introduction to Statistics and AP Biology video. In the first part of this video, we're going to talk about standard deviation. Standard deviation is the most widely used measure of variability. The sample standard deviation is essentially the average of the distance between each measurement point in the sample and the mean. The larger the spread of data, the larger the standard deviation. So we're going to look at these two examples of standard deviation and why they're important for us to understand. What you're given in figure 1 is the test mean or the averages for two different teachers. So you have here the the average for each of the student plots, and same scale is used on this side. So you have teacher 1 here and teacher 2 here. The first question asks, how does the mean for teacher 1 compare for the mean of teacher 2? Now, this line right here represents the mean of the test grades, but it's also written here that the mean for both teachers is exactly an 80. So after the test grades for these two different teachers, same test, two different classes, you can see that the average for both of them is the same. The next question asks, the two figures show what kind of data was gathered for both teachers. How would you describe the distribution of test grades for both teachers? In other words, each of these dots represents a test grade for these teachers. And so when you look at the mean, it comes out exactly the same to 80. But the difference between these two teachers is that for teacher 1, the grades are pretty close together. You can see that nobody failed the test. Nobody got an A either, but all the grades were around an 80. For teacher 2, you can see that 3 of the students failed the test, and 3 of the students did really well, getting a 90 or higher on the test. So then on question number 3, when it asks us which data set has the larger standard deviation, what you need to remember is this one sentence in the introduction. The larger the spread of data, the larger the standard deviation. So for number 3, which data set has a larger standard deviation? That would be teacher 2. So when we're looking at standard deviation, we can use what is called a normal curve to find out where our data falls. And this is what a standard deviation curve looks like, with the 0 representing the mean, and then from the mean going either positive away from the mean or going negative away from the mean. It says, in figure 2, the numbers at the bottom axes are what are known as your standard deviations. So you can see they go from 0 to +3 and 0 -3. Part A asks, what percentage of the data falls between -1 and 1 standard deviation? And it gives you a hint here. Add up the percentages. Shade in the area between -1 and 1 standard deviation in blue. So I'm going to start from 0. I'm going to go ahead and kind of make a mark here at number 1, because we're going to go between 1 and -1 standard deviation. So from the 0, I want to see that I'm going to shade in the area between this one and -1, all this area in between in blue. And now to figure out what percent of the data is going to fall within 1 standard deviation, I'm going to add up each of these values. And I can simply use a calculator for this. So 15.0 plus 19.1 plus 19.1 plus 15.0 would give me 68.2% of the data is going to fall in that blue shaded area, or 1 standard deviation above and below the mean. Part B asks what percent of the data falls between -2 and 2 standard deviations. Shade the area in yellow, or shade the area for -2 and +2 standard deviations in yellow. So again, I'm going to go and shade the data from -2 all the way to +2. So this is the data that falls between -2 and 2 standard deviations. And when I add up all the percentages, it comes out to 95%. Now on the next page, you and your group mates in class will be given data to figure out what each of these values are and where grades fall for example students. Part 2 of this activity deals with standard error of the mean, or what we call SEM. Standard error of the mean, or SEM bars, are helpful tools in determining if there is a statistically significant difference between two sets of data. For an example, a control and a test group. And it's very important that we distinguish between a difference and a statistically significant difference. SEM bars are going to help us identify when there is a statistically significant difference. Typically in biology, data will be represented with bar graphs, and then SEM bars, which are these pieces right here, those are the SEM bars, will be drawn in as shown as figure 3. So when we look at the SEM bars, we have to ask ourselves the question, do the SEM bars overlap? Now, when I say overlap, I am talking about just this line right here, this vertical line. And we want to see, is there a difference in the data sets between these two values? So even though the bar graph does show a difference between the data sets, we then look at the SEM bars to see if there's a statistically significant difference. So you can see here that the bars do not overlap. In other words, the top of this bar does not cross into the range that the bottom of this other bar does. Whereas on this graph, the top of this bar is definitely in the range of the bottom of this bar right here. So if the SEM bars overlap, we cannot say there is a statistically significant difference between the two sets of data. If the SEM bars do not overlap, then we can say there is a statistically significant difference between the two sets of data. Now, you are not going to be asked to calculate statistical differences, but you are going to be asked to draw graphs and interpret statistical differences. I hope this video was helpful. We'll be practicing these in class next time. Thanks for watching. Bye.